Okay, so now that we're introduced to polynomials of several variables, the first thing we want to do with them is talk about how we add them and subtract them. So recall, when we're adding and subtracting polynomials, what it basically comes down to is we need to combine like terms. And so nothing really changes here. The variable part has to be exactly the same. So here's a couple of perfect square trinomials. I'm adding them together. So inside there's no like terms, so I can't simplify inside. Same thing here. Nothing going on inside the parentheses, so I can basically drop them. Now again, I like to do things horizontally, but if you like to do them vertically, I'm pretty sure you can just line up the like terms. And as I look at this, here's a term with a squared, and here's a term with a squared. So how many a squared terms do we have? We have two of them. Right? Here's a term with AB, and there's another term with AB, and they're actually opposites, right? We're adding 2AB and subtracting 2AB. So they actually cancel each other out. And then we have a b squared and a b squared, so we have a total of 2b squared. And so there's our example of adding polynomials. If we added two perfect square trinomials, the result would be 2a squared plus 2b squared. Again, I did it horizontally, but those who like to do it vertically, here's what the work would look like. You basically just line things up like term to like term. So there's the first polynomial. The second one, I put the a squareds under a squareds. I put the ab's under the ab's. And I put the b squares under the b squares, right? And you can see those cancel out. There's my 2a squared and my 2b squared. So again, we're just combining like terms. So looking at some more examples, if we're adding, right, I've got my difference of squares being added to a perfect square trinomial. Again, I can't do anything inside either one of these. Nothing is going on outside of them, so I can just simply drop the parentheses and then just start going, right? So a squared, there's two of them, right? There's only one term with ab in it, so we get 2ab, and then we have a minus b squared and a plus b squared, so they actually cancel out. So that's what would happen if I took the difference of squares and added it to its perfect square counterpart, right? So there's the end result. And moving forward, right? So this one's kind of a train wreck. We've got all kinds of things going on. Again, we are adding two trinomials. Nothing I can do inside of here because no terms are like, and same thing in here, no terms are like. No distributions going on, so we can basically drop the parentheses. And then just start going term by term. This one, again, notice everything is degree 3. So again, the idea is we'll let x decrease in value, in terms of degree, and we'll let y ascend. So as I do that, right, we're going to start off with 3x cubed. That's the highest degree on x that I see. So 3x cubed is the only one that I see, so that's it. Next, we're looking at x squared. Well, here's an x squared y. And here's an x squared y. So those two terms are like. We're subtracting 2 and adding 3, so the net effect is I've got 1. All right, so decreasing in x, we got degree 3, degree 2, so I'm expecting a degree 1, and that's happening right there. Right? As a matter of fact, that's the only term with that, so there's nothing else like it. All right, and then as we decrease in terms of x, we're increasing in terms of y. So I'm expecting my y cubes to be next, and lo and behold, there's a term with y cubed, and there's a term with y cubed. Combining them, we're adding 4 and subtracting 2, so the net effect would be positive 2y cubed, and there's a nice arrangement of our addition of those two trinomials with all kinds of different degrees. We're combining like terms again, and standing operating procedure is to start alphabetical, let one variable decrease in degrees, and let the other one ascend. And last but not least, what about subtraction? Well, it's the same thing. The subtraction needs to be distributed, so all my signs change behind it. So we're going to drop these parentheses up front and change all the signs behind it. and then we're basically back to combining like terms. Again, thinking in terms of a descending order in x, we'll begin with x squared. So those combine up to negative 2x squared. The next thing would be x to the first power, so there's 1 and there's 1, and they both happen to be like. They're both x times y. So plus 4 minus 2 gives us a positive 2xy. And then in terms of y, there's a y squared, here's a y squared, and that combines up to 6y squared. So nothing really changes. There's just more to track, if you would, because there's more degrees, there's more variables, and so there's just a little bit more to look at. But adding and subtracting polynomials with several variables comes back to the idea of combining like terms. And that's almost sounds like a broken record, right? We've been combining like terms since the beginning. Classic situation. All right, so our next order of business then is multiplication, and I bet you guys know what's coming next, right? Distribution, distribution, distribution. We'll do some examples in the next video.